Cloud computing. What is cloud computing? How does cloud computing work? Cloud computing infrastructure. Models of cloud computing. Types of cloud environments. What is cloud computing? Cloud computing is the delivery of on-demand computing services from applications to storage and processing power, typically over the internet and on a pay-as-you-go basis. How does cloud computing work? Companies want to avoid the upfront cost and complexity of owning and maintaining their own IT infrastructure. Thus, companies rent access to applications, storage, or processing power from a cloud service provider. Companies pay for what they use when they use it. Cloud computing allows companies to minimize upfront IT infrastructure costs, allows enterprises to get their applications up and running faster with improved manageability and less maintenance. Cloud computing enables IT teams to adjust resources to meet fluctuating, unpredictable demand. Cloud computing relies on sharing of resources, where providers of cloud computing services can benefit from significant economies of scale by delivering the same services to a wide range of customers. Cloud providers typically use a pay-as-you-go model. Economies of scale are the cost advantages that enterprises obtain due to their scale of operation by doing things more efficiently, with increasing size. Cost per unit of service decreases with increased scale. Cloud computing infrastructure. Cloud computing infrastructure is the collection of hardware and software elements needed to enable cloud computing. Cloud environment uses virtualization technology to combine computing resources into shared pools and automatically provision them depending on organizational needs. This allows an enterprise to scale and maximize resource usage. In this regard, virtualization refers to the act of creating a virtual rather than actual version of something, including virtual computer hardware platforms, storage devices, and computer network resources. So, virtualization means to create a virtual version of a device or resource, such as a server, storage device, network, or even an operating system, where the framework divides the resource into one or more execution environments. Devices, applications, and human users are able to interact with the virtual resource as if it were a real single logical resource. In this context, a virtual machine refers to a special piece of software which emulates the operation of a physical machine, despite being located within a real physical host and making use of its resources. A virtual machine remains completely independent. It uses its own software-based component, whether the CPU, motherboard, video adapter, network interface, memory, and hard disk, which may even differ from those of the host and runs its own operating system and the applications. Operating system the virtual machine is installed on is called the host operating system, while the operating system of the virtual machine itself is referred to as the guest operating system. Each guest operating system starts up and runs in an individual window on a host operating system similar to an ordinary program. All the virtual hardware which powers the guest operating system is handled by a special engine called a hypervisor. A hypervisor is known as Virtual Machine Manager. It allocates physical resources to each of the systems and ensures that they do not interrupt each other. As a rule, hypervisors are implemented on the software level, but there are also ones embedded into the system firmware. Now, a physical server includes memory, processor, network connection, hard drive, and an operating system for running programs and applications, while a virtual machine is a software computer used as emulation of an actual physical computer. A virtual server operates in a multi-tenant environment, meaning that multiple virtual machines run on the same physical hardware. In this case, the computing resources of a physical server are virtualized and shared among all virtual machines running on it. The architecture of a virtual server is a little more complex than that of a physical server. Thus, a hypervisor, such as virtual machine, is installed on top of physical hardware. A hypervisor is then used to create and manage virtual machines, which have their own virtual computing resources. After that, you can load multiple guest operating systems and server applications on top of the virtual hardware. Thus, virtual servers allow you to run several operating systems and applications on the basis of the shared physical hardware, which makes it a more cost-effective option than a physical server. So, cloud computing infrastructure includes computing power, networking, and storage, as well as an interface for users to access the virtualized resources. The virtual resources mirror a physical infrastructure with components like servers, network, switches, memory, and storage clusters. Network resources can include virtual routers, firewalls, bandwidth, and network management software. Cloud computing can be broken down into three models: infrastructure as a service, platform as a service, and software as a service. First, infrastructure as a service. In this model, cloud customer can rent the fundamental building blocks of computing such as servers, storage, and networking from cloud provider, where a cloud provider hosts the infrastructure components including servers, storage and networking hardware. And customer can access resources and services through a wide area network WAN, such as the Internet. Infrastructure as a service provides an easier, faster, and more cost-efficient way to operate a workload without having to buy, manage, and support the underlying infrastructure. It can be seen as pay-as-you-go model. It is an effective model for workloads that are temporary, experimental, or that change unexpectedly. It cuts ongoing maintenance costs. However, infrastructure as a service isn't secure enough for most critical data. Common scenarios where infrastructure as a service, test and development environment, website hosting, storage, backup and recovery, web applications. Platform as a service. Platform as a service is the next layer up, as well as the underlying storage, networking, and virtual servers. This will also include the tools and software that developers need to build applications on top of. That could include middleware, database management, operating systems, and development tools. Platform as a service builds on the infrastructure as a service model, where in addition to the underlying infrastructure components, we find that providers host, manage, and offer operating systems, middleware, and other runtimes for cloud users. Platform as a service is a complete development and deployment environment in the cloud, with resources that enable you to deliver from simple cloud-based applications to cloud-enabled enterprise applications. Platform as a service is designed to support the complete web application lifecycle, including building, testing, deploying, managing, and updating web applications. In this context, you manage the applications and services you develop, and the cloud service provider typically manages everything else. Common scenarios for platform as a service are development framework, analytics or business intelligence, workflow and security services. Software as a service. Software as a service is the delivery of applications as a service, probably the version of cloud computing that most people are used to on a day-to-day basis. The underlying hardware and operating system is relevant to the end user, who will access the service via a web browser or application. It is often bought on a per-seat or per-user basis. With software as a service, providers host, manage, and offer the entire infrastructure as well as the applications for users. A software as a service user doesn't need to install anything. The user simply logs in and uses the provider's application, which runs on the provider's infrastructure. Common examples are email, calendaring, and office tools. Software as a service provides a complete software solution which you purchase on a pay-as-you-go basis from a cloud service provider. You rent the use of an application for your organization and your users connect to it over the internet. Software as a service allows your organization to get quickly up and running with an application at minimal upfront cost. Common software as a service scenarios: a web-based email service. With this service, you log into your account over the internet, often from a web browser. The email software is located on the service provider's network, and your messages are stored there as well. You can access your email and stored messages from a web browser or any computer or internet-connected device. For organizational use, you can rent productivity applications such as email, collaboration, and calendaring. More, you can rent sophisticated business applications such as customer relationship management (CRM) or enterprise resource planning (ERP). You pay for the use of these applications by subscription or according to the level of use. Types of cloud environments. A company that needs cloud computing services can choose to use a public cloud, a private cloud, or a combination of the two, known as a hybrid cloud. Public cloud is where cloud services are hosted by a cloud service provider and shared with other tenants. With public cloud services, users don't need to purchase hardware, software, or supporting infrastructure which is owned and managed by service providers. Public cloud provides a shared platform that is accessible to the general public through an internet connection. Public cloud operated on the pay-as-per-use model and administrated by the cloud service provider. Advantages of public cloud: low cost, where public cloud has a lower cost than private cloud as it shares the same resources with a large number of consumers. Next, location independent. Public cloud is location independent because its services are offered through the internet. Next, public cloud saves time. In public cloud, the cloud service provider is responsible for the management and maintenance of data center in which data is stored, so the cloud user can save time to establish connectivity, deploying new products, release product updates, configure and assemble servers. Next, quickly and easily set up. With public cloud, organizations can easily buy public cloud on the internet and deploy and configure it remotely through the cloud service provider within hours. Next, business agility. Public cloud provides an ability to elastically resize computer resources based on the organization's requirement. Next, scalability and reliability. where public cloud offers scalable and reliable service to the users at an affordable cost. On the other hand, disadvantages of public cloud: low security. Public cloud is less secure because resources are shared publicly. Performance: in the public cloud, performance depends upon the speed of the internet connectivity. Public cloud is less customizable than the private cloud. Next, private cloud. A private cloud is infrastructure operated solely for a single organization, whether managed internally or externally by a third party, and hosted either internally or externally. Private cloud is a self-service interface that controls services, allowing IT staff to quickly provision, allocate, and deliver on-demand IT resources. Private cloud includes highly automated management of resource pools for everything from compute capability to storage, analytics, and middleware. Private cloud provides sophisticated security and governance designed for a company's specific requirements. Advantages of private cloud: private clouds have more control over the resources and hardware than public clouds because it is only accessed by selected users. Next, security and privacy are one of the big advantages of cloud computing. Private cloud improves the security level as compared to the public cloud. Next, private cloud offers better performance with improved speed and space capacity. On the other hand, disadvantages of private cloud includes high cost, where the cost is higher than a public cloud because setup and maintenance of hardware resources are costly. Next, private cloud includes restricted area of operation, where private cloud is accessible within the organization, so the area of operation is limited. Next, private clouds are scaled only within the capacity of internal hosted resources, so it provides limited scalability. Next, private clouds require skilled people to manage and operate cloud services. Next type of environments is hybrid cloud. Hybrid cloud is a combination of public and private clouds. A hybrid cloud uses a private cloud foundation combined with the strategic integration and use of public cloud services. Hybrid cloud allows companies to keep the critical applications and sensitive data in private cloud or a traditional data center environment. Hybrid cloud takes advantage of public cloud resources like software as a service for the latest applications and infrastructure as a service for elastic virtual resources. Hybrid cloud facilitates portability of data, applications, and services, and more choices for deployment models. So, advantages of hybrid cloud: it provides flexible resources because of the public cloud and secure resources because of the private cloud. It is cost-effective. Hybrid cloud costs less than the private cloud. It helps organizations to save costs for both infrastructure and application support. It offers the features of both the public as well as the private cloud. A hybrid cloud is capable of adapting to the demands that each company needs for space, memory, and system. Hybrid cloud is secure because critical activities are performed by the private cloud. Hybrid cloud provides an excellent way for companies to manage the risk. On the other hand, disadvantages of hybrid cloud include networking issues, where networking becomes complex because of the private and public cloud. Infrastructure compatibility is the major issue in a hybrid cloud. With dual level of infrastructure, a private cloud controls the company and a public cloud does not. So there is a possibility that they are running in separate stacks. Next, the reliability of the services depends on cloud service provider.